So I want to look at one application, and then I want to look real quickly at another application related to rational functions of something we did before, the polynomial long division. Okay? So first of all, our application, just to see how something like this could be used. Here's a formula that they were able to come up with. It says for a person with sensitive skin, the amount of time t in hours the person can be exposed to the sun with minimal burning can be modeled by this function here. And notice, s is greater than 0, okay? So t is our time in hours, okay? And then we have this value s, and s is greater than 0 and less than or equal to 120. Now, we also defined here what s is. S is the Sun-Sohr scale reading. The Sun-Sohr scale is based on the level of intensity of UVB rays. So this is a scientific rating of how intense the sunshine is in a particular day. Obviously, it can't be 0 or else it wouldn't be daylight. Okay? So we wouldn't have any sunlight. So, a couple of questions here. Find the amounts of time a person with sensitive skin can be exposed to the sun with minimal burning when S is 10, 25, and 100. Now before we do this, what are we going to do to solve this part?
Plug the S values into the T formula?
Yeah, we're just plugging them in, okay? Don't overlook problems like this that are easy, okay? Alright, just because we're in a topic that may be a little more challenging and it happens to be a word problem, watch out for these parts that are really easy, okay? All they're asking you to do is plug in 10, plug in 25, and plug in 100, okay? So let's actually do that. Let's break down the labor here. How about if you guys do 10, and you guys can do 25, and you guys can do 100, alright? So take a moment and let's figure out how much time someone could stay out when the intensity is those different values.
Oh, no, like you see, 0.608.
Okay, when S is 10?
2.75.
2.75. Alright, good. That's what I got. How about 25? 1.332? Is that what others got? Okay, 1.332?
Wait, others 1.3.
322? Okay. Thank you. And how about for 100?
0.608.
0.608.
Yeah.
Alright, now if we wanted to convert that to minutes, we could. Alright, it doesn't ask us to, it just says the amounts of time. But all these units of time are in hours, okay? So when the sun is not very intense at all, you could be out there for 2 hours and 45 minutes and not really get burned. Okay? However, when the intensity is 100, you could only be out there for about 36 minutes or so before you're going to start to get burned. Okay? So that's a little scale that they could use to determine, all the recommendations that are made. Oh, you need to wear sunscreen if it's if you're gonna be out for this long or whatever. You know, those recommendations are based on models that they come up with, similar to this, okay? Now, part B, if the model were valid for all s greater than 0, what would be the horizontal asymptote of this function,
Yeah.
and what would it represent? Let's think about this. What would be the horizontal asymptote?
Do you plug in 120? That would be
No.
037 over 1.
What?
037 over 1.
Okay, t equals
037.
0.37 over 1, right?
The same.
Okay, so t equals 0.37 hours would be the horizontal asymptote.
Why would you use 1? Like, how would you know it's not like
Because
0.01?
it's S over S.
Well, yeah, you have the same exponents, right? How do we find horizontal asymptotes?
Oh.
Look at the degree of the numerator and denominator,
Oh.
all right? So,
I get it.
what does this mean? 0.37 hours. What does that mean?
It's like
That in
you'll
this
always
one is
be
not
able
going
to
to
be out
touch.
in the sun
That
longer
means-
than that.
Wait, what'd you say?
You'll always be able to be out in the sun longer than 0.37 hours.
For 0.37 hours or under, you won't get burned.
Okay, yeah, and what you're saying is kind of same idea as just looking at different sides of it. The minimum you'll ever be able to be out without getting burned. Wait, no, sorry. The maximum you could be out and guarantee you won't be burned no matter how intense the sun gets would be 0.37 hours. Okay, so about 20 minutes or so. It doesn't matter how intense the sun is, you're not going to get burned. Okay? So if you're just going to go out, you know, on a 15-minute jog or a 20-minute jog or something, or a 20-minute bike ride, you don't need to slather up with, you know, with sunscreen no matter how intense the sun is, because you're not going to get burned. Okay? So that's what that means. And that, guys, is how a horizontal asymptote can be used to tell us something about a situation. Okay? So, and notice this is a person with sensitive skin. They would have different models for people who have regular skin or whatever. Or people who already have a base tan can be out for a while longer than someone who hasn't seen the sun in 8 months. You know, if they're from the north. Okay? We used to come down for spring break from Ohio. And up in Ohio, you don't see the sun a whole lot from, you know, beginning of October through end of March or so. So we'd come down in March and be pasty white, and usually get burned. But anyways, so that's one application. Now, let's talk about this function here, and I want to look at one thing in addition to what we have looked at already. And this is a rule for slant asymptotes.
What?
Slant asymptotes. We'll see what this looks like here in a moment, but
Is it like the y?
understand the situation here. The situation is that this only will occur if the degree of the numerator is exactly one more than the degree of the denominator.
This one is not going to have that.
It will.
It will.
Because this is an x squared, this is x to the first. It's exactly 1 degree higher in the numerator than in the denominator. Okay? If I had an x to the fourth over like an x squared minus 1, that's not going to have slant asymptotes.
This won't have horizontal asymptotes either.
No, this can have horizontal and vertical asymptotes just like our other ones.
But if it's bigger on top,
Okay.
I thought it was none.
Oh, well, yeah. You would still go through and check this specific one. You would still go through and check.
But
Okay.
if it has a slant asymptote it definitely does not have a horizontal asymptote because the numerator still has to be bigger than the denominator, right?
It would be, yes. So you'll have one or the other. I get what you're asking, yeah. You're still gonna wanna check for what it'll have, okay? Now, let's run through the same things that we've been running through, and then we'll get to the last part here, the slant asymptote, and look at how to find that, okay? So first of all, our domain, what is x allowed to be?
It can't be 1.
X cannot be 1, alright? X cannot be 1. We just said the horizontal asymptote, we have bigger on top, none. So there is no horizontal asymptote,
Bot and comes with clutch.
okay? Vertical asymptote, no.
X equals 1.
X equals 1. Will the numerator factor? Will our numerator factor? No. Okay, so I'm not going to be able to factor out an x minus 1. Alright, so it's not going to cancel, which means this does give me a vertical asymptote at x equals 1. So I'm actually going to sketch that here. There's my vertical asymptote at x equals 1. And I kind of, if you were looking closely, I didn't even put hole on there because we don't have any holes.
Oh.
Alright? Now, for zeros, what would our zeros be?
It's x. It's plus or minus square root of 2/3.
Yeah, set the numerator equal to 0.
Is that,
Negative 3x squared plus 2 equals 0. X squared equals positive 2 over positive 3. So x is the square root of 2/3. Can someone help us out and tell us what that equals? Plus or minus
0.81 or 0.82.
0.82. Okay. So watch this here. My zeros are going to be at 0.82 and negative 0.82. Now that's interesting. Both of them are on the left side of that vertical asymptote.
You knew that would happen.
oh,
Okay.
so it's gonna fall in between.
Well, we'll see here. We'll see here. Okay, so x, we have the points plus or minus 0.820. Okay, what's our y-intercept?
-2.
Negative 2.
0, -2.
Yeah, 0, negative 2. If you plug in 0 for x, you get 2 over negative 1. So negative 2. So now we have, and I'll plot that point here. Now we have this idea of the slant asymptote. Okay? The slant asymptote. Because the degree of the numerator is exactly 1 more than the degree of the denominator, we can find a slant asymptote by using polynomial long division. Now, let's look at how this works, okay? You guys know how to do the long division. Alright, so I actually have all the work shown here for us. Come on, go away. There we go. So here's the work on the polynomial long division. And you'll notice we got a remainder of negative 1. Okay? So, I mean, we could write this whole thing as negative 3x minus 3 minus 1 over x minus 1. Okay, that's the whole quotient. However, notice we got a linear
Bless you.
a linear expression here for everything that other than the remainder. Okay? That line right there is our slant asymptote. Okay? So the slant asymptote here is the line y equals negative 3x minus 3. Okay?
So in order to find it, you just have to do long division, numerator divided by denominator.
Mm-hmm. Yeah, do the division that the rational expression
Or synthetic division.
is. In this case, you could do the synthetic division. Yeah. Okay. If it were like a x cubed divided by an x squared, obviously you guys know you can't do synthetic division when you're dividing by an x squared. But yeah, if it's a linear, you can. So watch what this looks like. Okay. Here's the line y equals negative 3x minus 3. So here's negative 3, 1, 2, 3 over 1. Okay. Here is my slant asymptote. It should hit right here, and then there, and then there, and then there. So you see what happens here. It's kind of interesting to look at this. I'm going to extend this side here. And one thing that you'll want to do is make sure you draw your asymptotes long enough so you can actually approach them. But notice all three of the points that we just found, or we already found, are up in this like quadrant of these two crossed lines. Okay? Now you guys know that when we have a hyperbola, usually we'll have some crossing asymptotes, and we'll kind of be on opposite corners of those two crossing asymptotes. The same thing is going to apply here, though. But watch what this looks like. We're going to go through this 0, and we're going to approach this vertical asymptote. We're going to go up through this 0, and we're going to approach the slant asymptote. Okay? Then, if you look kind of across from that, it's going to do kind of the same idea in this bottom little quadrant here. We're going to have some points here, and it's going to approach the slant asymptote, and it's going to approach that vertical asymptote. And that's what that'll look like. Okay?
For this limit asymptote, you don't use the remainder.
You don't use the remainder, no.
So whatever you do on that is the other side?
Yeah, basically you'll just have like a mirror image kind of thing.
How can I know the function has a slant asymptote?
You know the function has a slant asymptote because notice the degree in the numerator was 2 and here it was 1. If this is just one more than this, you're going to have a slant asymptote.
Only one more.
Only one more. It's got to be exactly one more. If you've got an x to the 4th and an x cubed and some other stuff, you're going to have a slant asymptote. If you had an x to the 4th and an x squared, you're not.
So, if you have an x to the 4th or an x to the 3rd, you can find a slant asymptote, or you will have one,
You will have one.
no matter what.
Yeah, you need to divide and find out what that is.
There's no exceptions to it?
I guess if it's fully reduced, okay?
Gotcha.
I mean,
Oh,
theoretically,
yeah.
you could have an x to the 4th over an x cubed, but all three factors in the denominator are going to cancel out, so you just have 3 holes in a line.
Yeah.
But that's different. So yeah, we're talking about rational functions, and rational functions are always reduced. So yes, in every rational function, if you have a difference of 1 there, you'll have a slant asymptote.
On the test, we should be able to know how to figure out domain, horizontal, and vertical asymptotes, zeros, y-intercept, slant asymptote, and holes.
Yes. Yeah. Okay. Do you want to get a drink, or you okay? Okay.
So that isn't a line though, it's still curving, like the part that goes like almost straight.
What, like the red part that's approaching it?
No, the one that's like, yeah.
Yeah, this is just constantly approaching this green line, the asymptote. Okay? So it's not a straight line just going parallel to the asymptote. It is continually approaching it as you go off to infinity.
Yeah, because the other one looks almost like a line.
Yeah. Just because it's a little crayon, so. Okay. Hang on. Alright, so I've given you a couple here. Alright. Now, 427 to 30. There are some directions here. You can ignore the directions. Do basically what we did. Do what we did, okay? Determine asymptotes. Domain. Poles. Get zeros. Y-intercept. Okay. Do all of that. And then here they have some, again, some matching where you can match the function with its graph. Okay?
So we're only matching 2 of them, or each one is like its own?
Yeah. Which of these 4 functions
Oh, I get it.
is this the graph of? Same thing here. Which of these 4 functions is this the graph of? Okay, so I'm going to give you guys the last 8-9 minutes here to start on these, and you can practice, ask questions. Tomorrow we're going to start with some questions, do a little bit more practice, and then you'll have your test for the remainder of the fusion
So it's
period.
on both?